Welcome to the first video in our cityschema.org series on coordinating city modeling activities. This sequence of videos and documentation are supported by the Boston Planning and Development Agency, Department of Digital Cartography and GIS. And our goal is to engage a variety of stakeholders in the development of a metropolitan scale 3D model that represents current, past, and future streetscapes. We'll introduce the BPDA Citywide Model Collection and its goals, some applications, and the GIS management scheme. And we'll teach you how to use your favorite modeling tool to download city model resources with detailed terrain and building model collections, to keep your local models in sync with the BPDA's collection, to maintain registration with Metropolitan 3D coordinate system, which will allow you to very easily snap in updates from other users and to share your updates without any guesswork in terms of location. And without any further ado, let's look at the BPDA's model. Let's take a look at the Boston 3D model as a web scene. From the Boston Planning and Development Agency's website, we can just Google the 3D model and go visit it here. For best results, we'll go to full screen mode, and we can fly around in this model collection. It's a diverse collection of models representing buildings that were captured in a photogrammetric survey in 2011 and turned into 3D models by a company named CyberCity 3D. Notice for each model we have a lot of information, including an address, a name. We can go to the parcel information from the property tax assessor. Get some parcel information for each of these models. If you want to see a model of buildings that don't exist yet, for example, the South Station project, we can look at that here. And let's get more information about this model. As you can see, its status is under construction. Its name, South Station Air Rights. Information about how we know that the project is going on. Credit for the model. We also have a link to the BPDA's project archive, the document management system, with all the information about the approval process for this particular project. This, as I said, is a diverse collection of models that includes some nice bridges by the BPDA's in-house modeler, Tae-Ming Chang. And these are handmade models. You can think of them as being valuable works of art. In fact, what this system is really a content management system that is four-dimensional. Each building is tagged with its start date and end date, and so we're capable of preserving models of buildings that don't exist anymore. Another interesting feature of the model is the walls and docks. that clean up this terrain, the edges of the terrain model. These were also captured from this photogrammetric survey. One of the nice things about having all of these models in a geographic information system is that they can be combined with other geographically referenced information, such as regulatory information, information on sea level rise. Let's look at that one. An interesting 3D layer in its own right. There's the nice people in the digital cartography office have given us a number of layers that we can look at in the context of this 3D model. And as you can see, it covers all of the city of Boston. Alongside the public-facing web scenes we were just looking at, the model management system can be used for internal agency projects, for analysis, design review, sketching ideas for internal discussions for special planning districts. And one of the exciting aspects of this is the work going on at ESRI with the ArcGIS Urban application, which the BPDA is actively investigating and collaborating with. The model management system is really an asset management system that is capable of storing multiple representations of the same building, such as we have here, building models that were compiled at different times for different purposes with different technologies at different levels of detail, can all exist at the same time within the model management schema. Likewise, models of previous conditions, proposals that may have been superseded, and proposals that were approved can be preserved. It's an interesting aspect of a system like this that as the city model moves forward in time, it preserves the historical information, which is just a byproduct of updating the city model, but also can be used as a tool for historical research for its own sake. Models can be created representing former time periods, and the temporal referencing scheme will permit historical representations of the city to be activated with a time slider. This is all managed with the geographic information system. We're using ArcGIS Pro right now to compile the city model using a variety of sources. Mainly, we're using wholesale observations such as LiDAR, 3D photogrammetry, model reduction tools that create streamlined 3D models from photogrammetry and LiDAR, terrain models, and so on, are all compiled into the citywide model, and a variety of tools are used to export these models to proprietary Esri formats that are very efficient for citywide visualizations and web scenes, and open format representations that can be imported into a variety of 3D design tools. One of the main products of this is the Open Repository Catalog, which permits an archival grade asset preservation modality, integrity audit and repair, and accessibility to open source tool chains. This open format repository is based on the reference model for Open Archival Information Systems, OAIS. Another view of this scheme will be covering this workflow in a few minutes during this video, using the open format repository to begin a design project in our favorite design tool of your choice. Then new models can be created and posted to the GIS management system. As time goes on and these models, editable design projects might become ready for updates for new models that have been added subsequently, updates can be pulled in from the catalog repository. Ultimately, we anticipate and we hope that by providing free tools for doing internal asset management, that we'll have a lot of collaborators in the region, both neighboring towns, universities, historical research projects, engaging with this sharing scheme to build a network that provides a basis for regional city modeling. Might be used for virtual reality, augmented reality, design, and research. Let's begin our modeling project by seeing what kinds of resources we can find at the Boston Planning and Development Agency's 3D data download site. This site is the web representation of the city model catalog and repository that's generated by the GIS model management system. You can see that the city model has been broken into these bite-sized chunks. Each tile is 5,000 feet. And for each tile, we have a terrain model generated from a 2011 photogrammetric survey. For any one of these, if you want to read more about it, you can click the blue info dot, which will give you full metadata for each of these components. This terrain model is matched with a base map, a planimetric ground plan from the same photogrammetric survey. We have the full collection of building models for this tile, individual OBJ wavefront object format models that are available individually or as a tiled collection, which we'll talk more about in a minute. You can, of course, read about that here. And a 2021 true ortho photo of this tile. We have DXF line work for all of the ground plan edges, building footprints, and DTM data, as well as contours. And all of these are open formats that should be importable into any tool. For convenience, we've also issued each tile as an all-in-one SketchUp model that has all of these components combined in a single file that employs layering and grouping and that sort of thing that is very convenient. We find that almost every commercial tool will import SketchUp and does a fairly good job of retaining those layer names, group names, and so on. So it's very convenient, even if it's not open source. So I encourage you to look at this site, click the blue info dots, and learn everything there is to know about these sources. We will go to tile H4 and the SketchUp model and just download that. I've already got it. We'll download the aerial photo by right-clicking and downloading that with a save link as. to get the ortho photo. Later on, we'll look at individual building models. So you can go to tile grid resources here amongst the citywide seamless data that we have and download the shapefile. Download the SketchUp format tile grid. If you want to learn more about the tile grid and the tile coordinate system, you can read this page. It will explain a little bit more when we get this into SketchUp. But for now, we'll just download this tile grid, which I've already downloaded. So we've collected a bunch of resources from the BPDA download site. Now we will go into SketchUp and start putting it together. We're going to demonstrate this method in SketchUp, but the concepts and procedures should be available and the same for whatever tool you're using. So here in our SketchUp model, we will start by importing the tile grid. The tile grid is a very large model. It's not large in terms of megabytes, but it is large in terms of extent. In this SketchUp object here, we can read about the tile grid. It's based on the Massachusetts State Plane Coordinate System, which is the official coordinate system for all surveying, public agencies, and so on. It's what your base models will come in if you're getting models from an engineer. But what we've done is we've offset that coordinate system, so we have a offset version of it with 0, 0 right here, instead of having the origin being somewhere in New York, which causes a very large, our coordinates to have a large number of significant digits. And here's the latitude and longitude of that insertion point should you need it. Now, a coordinate system this large is something that, with the offset, with this offset condition, we're able to share models across the Boston area with design tools. And this tile grid extent covers all of Cambridge, Brookline, Somerville, Everett. So we're hoping that this can be a unified coordinate system for coordinating city model activity. However, it's still a very large coordinate system as far as 3D modeling tools are concerned. So if you try to use a 3D modeling tool when your project is, say, this far from the origin, you'll notice a lot of problems. Things will seem as though they're working okay, and this applies all in Rhino, 3D Max, AutoCAD, SketchUp, FormZ, whatever tool you're using. These design tools are intended to be used with an origin that is near or in your project. And if you try to use our data in this citywide coordinate system, or Metro 3D coordinate system as we call it, you'll notice a lot of choppiness. You'll notice imprecision when you try to draw small objects. They will tend to snap in awkward ways and collapse. Your views will be clipped when you try to render things in perspective. The computer will appear to be confused. And so don't try to use our 3D modeling resources in this coordinate system. The trick I'm about to show you is how to use your own project coordinate system, but retain this tile grid and this insertion point in your model so that you're able to communicate easily, to download updates, to upload updates in the original coordinate system. And so you'll have the best of both worlds, the ability to take data repeatedly from city model collaborators, and also to share your data and eliminating all guesswork about the positioning of your contributions. So here we go. Our project for this demonstration will be up here near the Boston Common, and we're going to choose a project origin that is right here, but let's say Park Street Station. And so I'm going to just grab my model here. We'll just zoom in, and this is an operation that you can adjust later, but the key is that we have now dragged this tile grid, so we have a project origin which is near our project, and we also have a reference for the Boston Metro 3D tile scheme with its insertion point here. So the next step will be to import our tiled model. So I'm going to go import. Here's our tile H4. It'll take SketchUp a little while to load this large model into its memory, and when it does, our little blue weight icon will turn into the move crosshairs, inviting us to insert this import. Now notice if we insert the model here at 0, 0, it'll show up where it should have in the original coordinate system. But if we insert it here in the Metro 3D insertion point, you see it snaps right into position relative to the other tiles. This is something we should check here. So it may take SketchUp a little while to get comfortable with this model. You can look in the outliner if you'd like to help SketchUp a little bit. You can see in the outliner that you can turn off this component, which is our tiled model. Each tiled model will be its own component in the outliner, and the tile grid itself is a component as well, and this outliner is a very handy tool for being able to flick them on and off. One thing that you should check when you're doing these imports is to make sure that your tile grid is properly registered with the model and vice versa. So one way to look at this is to get down to a corner, turn off the tile grid. You can see that each module, each tiled model, has its own tile boundary. So we can see this here. The tile frame is a layer, and it aligns perfectly with the tile corner of this tile grid. And that assures that we're at the proper elevation and also XY. Let's look at the details here. Going back to the SketchUp tags panel, which is used to be known as layers. I still kind of think of this as layers. We can see that the model is broken down into several different layers, including the layers of building models according to their status. We have wall models, we have the terrain model, and we have docks. There's some docks over here on the Charles River. Let's go in and look at this terrain model. The terrain model came from a 2011 aerial survey, and turn off these buildings. so that we can get a notion of this bridge right here. You can see the terrain model is very detailed. It comes from a digital terrain model that's made of contours, break lines, and mass points. The break lines are most important. In fact, the contours aren't used here, but the break lines are showing exactly where this terrain should be creased. And the nice thing about it is that it is completely logically consistent with this ground plan, which was from the same photogrammetric survey. It's triangulated. Everything in this model is a triangulated mesh, including the buildings. And so this is a property of our GIS model collection. When we're managing the data in GIS, these 3D models have to be triangulated, and we'll talk more about that later. If you'd like to clean up the view, you can always turn off the edges, turn off profiles, and get a nice cleaned up view of the terrain model and the buildings. Of course, when you're editing, you need to have your edges on, and profiles are helpful as well. So the 3D model, very handy. Just to make this a little bit more agile, I'm going to turn off the buildings and the walls. Let's talk about updates. Let's say we've been working on this project for a few months, and we learn that new projects have been approved by the BPDA and published, the models published on their website. And so this will be one of the reasons why we want to continue to be able to trade data back and forth with the 3D model repository. So we'll go back to the web and bring our model, our map back in here. Let's check H4 for updates. This is where the 3D model catalog starts to shine. You can see that for each of these tiles we have a complete collection of OBJ files for their building models, and we can see them by status here. We can see there's some models approved. Now it happens that this model collection is completely contemporary with the model, the SketchUp model, but over time your SketchUp model might become out of date and you may want to download these models. So as a demonstration, I'm going to go over here and get the model of the new T-stop that was modeled by Taiming Chang at the BPDA. So here you can see, by clicking on it, we can see that there's a lot of attributes for this model, including the credit. It was the model credit is from the BPDA Urban Design and Technology Group. And we also have an OBJ file for this model that we can download. And so we'll download that, which I already have, and we can go back to SketchUp. And just to streamline things, I'm going to turn off the 3D model, and we will begin to import that new update. So going to our SketchUp OBJ importer, we're using the SKIMP plugin for this. A very handy tool for importing OBJ files into SketchUp. Here's our OBJ. Notice there's also some metadata in here for that file. SKIMP provides us a preview of where this model is going to end up, and you can see that doesn't look quite right. One weird thing about wavefront object files is that the axes are rotated, and to properly orient them with a Z up, as they should be, you need to push rotate X one time. Now you can see the preview shows the model about where it would be in the original coordinate system, which is fine. The units of all these models are feet, which is something you all should remember, not inches. And we can now import this. So here in our outliner, we have the model, and we can zoom into it here. Zoom selection, there it is. And we can observe that the model is way out here where the original tile was. And here's the magic. We're going to simply register this model here with our project coordinate system by selecting it, which you can do in the outliner. The new station model is selected, and we can then move it with the move tool, and we initiate the move by clicking here on the project origin. You want to make sure that your tooltip says that you're at the origin. That initiates the move. We tell SketchUp the direction and the distance by clicking down here to our Metro 3D insertion point. And bingo, the model pops in exactly where it should. And we can demonstrate that by turning on the terrain model here, and voila, here is that model. So no guesswork in terms of sharing data back and forth with the 3D, our 3D collaborators, whether it be the BPDA or whether it be another collaborator like a fellow architect, or once we get this project installed in Cambridge and Brookline, you'll be able to snap these resources together instantaneously. So the next thing that we'd like to cover is how to create a model to share with our collaborators. So to do this, we will import a reference map. The 2011 ground plan is nice and it looks good, but for doing design work we may want a more up-to-date reference. And so we're going to import the 2021 true ortho photo. And we are going to import that as an image, not as a texture, but as an image in SketchUp. This ortho photo will be able to be visible even when we're editing inside groups. And as you'll see, we can snap it to the corner of the tile because all of these tiled resources are using the exact same tile frame. Then registration is a snap. And we've now installed this image. We don't see it. We can see it flickering here because it's exactly at 0, 0, and it's co-planar with the tile grid. And so to enjoy this a little more fully, we'll turn off the tile grid now. It's a good idea just for you SketchUp users to put this reference image on its own layer. We'll put it in, we'll add a new tag called 2021 ortho, and then use the entity info tool to move this to the 2021 ortho layer. And so now we can turn this reference on and off. So you modelers know that it's good to have a flat reference image to begin models on. We're going to start a model here in this, well, let's put it here in the common. We won't put a model in the cemetery. Let's design a new Park Street station. So we'll come over here and we have our reference image for Park Street. You can see that it's got a decent amount of detail in it. The pixel dimensions of these orthos and ground plans are 1 foot per pixel. And we'll just make a simple model here. And we can extrude it. And to make this more interesting, extrusions are easy to do, but here we'll make a hole in this just to show that this is more than just an extrusion. So now we've got our artsy T-stop. And our last thing to do while we're editing this is to align it with the terrain. So we'll turn on our terrain reference now. You notice it makes a difference here. We need to take this model. We'll group it just to make things a little easier. And then move this thing in the vertical axis so that it is not floating but well footed into the terrain model. So note the position here. Our goal now is to put this model and contribute it back to our 3D model collaborators, whether they be at the BPDA or within the firm or the agency. Anybody who wants to incorporate our project into their project. We'll just start by renaming the group Park Street Project. And as you can see, our project is right near the project origin. And that gives SketchUp a lot of agility here. But before we share this, we're going to move it back to the 3D Metro 3D coordinate system. And so let's turn that on. So as you're probably already anticipating, this procedure is the opposite of our insert procedure that we did before. We select the model and we begin a move. Okay, no need to click on it here because we've selected it in the outliner window. The move tool is now waiting for a reference point for the beginning of the move, which will be this insertion point here. We don't want to move our original model, so I'm touching the Control key, which is now moving a copy of this model. And to end the move, we're going to click the origin point here. Now we've got our Park Street project, a second copy of it. And I'll call this Park Street project for export. And we can zoom to this. And observe that it is out here where it should be in the coordinate system, in the Metro 3D coordinate system. Zoom back there. So now that we've got this in the right place for sharing with the Metro 3D collaboration, we're going to export it as an OBJ. So SketchUp exports OBJ files fine. It needs a plugin to import them, but we'll export it using the regular export function. And OBJ is one of the many export formats that we can choose. Let's look at the options here. We're going to export just the current selection. We're going to triangulate all faces. This is very important. We're going to export single-sided faces. We're not exporting edges. We need to export texture maps. And we're not going to swap X, Y, and Z coordinates. We're going to leave Z up, so we'll leave this box unchecked. Z is up. And we're going to name this project Park Street Project. Okay. And so the next thing that we're going to do is go back to GIS and import that, and you'll see how this operation using the coordinate system here has allowed us to create a project origin to use resources from the Boston BPDA 3D model and to communicate with that model by downloading updates and uploading updates in this regional coordinate system. And we'll see you in ArcMap in a couple of minutes. Now we're ready to demonstrate importing a model into the GIS-based model management scheme. And we're going to be following some of the steps in this documentation here about managing the building model collection in ArcGIS Pro. And if you'd like to do this yourself, if you've got ArcGIS Pro, you can go to GitHub, and this demo workspace with all of its tools and tasks is downloadable right here. And it should give you this project. What we're going to do is use some of the, and by the way, we'll have a complete video tutorial covering this documentation at a later time. For now, you can read the documentation here, and this will be updated. It's actually current as we speak, and but you can check back at cityschema.org as it continues to develop. So here in ArcMap, we're going to go to the tasks. We have an import task, and like I said, we'll go back into the context of this later, but for now we can just say import models, and ArcMap will provide us a tool that we can run first after filling out filling in the blanks here. We select the model file, our Park Street project OBJ, and we're going to put it into a geodatabase feature class. It's been prepared already. And this tool already understands the coordinate system. We can fill out lots of handy attributes here, but as you can see, we have our Boston mass state plane shifted coordinate system is installed here. And so we simply push run now and sit back as ArcMap converts this from an OBJ file into a multi-patch object. And we can assign it an ID, a unique model ID, which will register it with the catalog. And for the grand demonstration, here we have our new model at Park Street Station. No guesswork as far as the absolute location of that in X, Y, and Z. And to wrap up this presentation, I'd just like to once again thank the Boston Planning and Development Agency, Department of Cartography and GIS, for making this work possible. You can find more information about extending this city model architecture in your city at www.cityschema.org. And we look forward to seeing your models. Use the comment section to share your tips and tricks and whatever snags you might be having. We'll try to reply to those, and subscribe and to get alerts for new videos. This is a new project. We do anticipate problems, and we anticipate new solutions. So stay tuned and happy modeling.